Now, before we start to work out the areas of segments of circles, what we need to do is just recap on how we find the area of a triangle, because that's going to be used quite often in most problems. So if we take a triangle and label the angles ABC, the conventional way of labeling this side is a little a, and the opposite side to angle B, little b, and the opposite side to C is little c. Then, without proof, I'm going to tell you now that the area of the triangle, okay, is a half AB times the sine of C. And what this is saying is that essentially, if you know two sides, let's say A and B, okay, and you know the angle that is between these two sides, often referred to as the included angle, angle C, okay, then this is the formula that we can use. So, in other words, let's try this with a simple example. Let's suppose we have a triangle something like this. Let's go like that, okay? Let's suppose that this is, say, 4 centimeters and this is 5 centimeters. We're given two sides and the included angle is this one. Let's say that this angle in here is about 32 degrees. It's not drawn to scale, but let's work out the area. So the area would equal a half the product of the two sides, so that's 4 times 5, or 5 times 4, obviously it's not going to make any difference, times the sine of the included angle, so multiplied by the sine of 32 degrees. So make sure your calculator is in degrees mode, because we're calculating the trigonometric function sine of 32 degrees. If you use your calculator, what you find you get is 5.299 and so on. So because we're working in centimeters, the area is going to be roughly 5.3 centimeter squares if we round it to one decimal place. Okay, so let's try another example. This time the example that we're going to do will be in radians. So let's suppose then that we've got a triangle something like this, again not drawn to scale. Let's suppose that this is 8.3 meters and this side here is 6.1 meters. So we have our two sides and we're looking for an included angle. The included angle is this one. It's in between these two sides. This angle, let's assume, is 0.9 radians. Okay? Remember, radians can be written as either 0.9 with a little c there, or just simply left as 0.9. Okay, so I'll leave it as 0.9 radians then in text here. So if we've got to work out the area of this triangle, the area is equal to half the product of the two sides. So these are the two sides, so we've got 8.3 times 6.1, and we've got multiplied by the sine of the included angle, which is the 0.9 radians. Okay? Make sure that your calculator is now converted to radians mode, okay, and that you know how to do that. And if we work this out, you should find you get 19.829 and so on. And if we round this up then to one decimal place, we're working in meters, so the area would be 19.8 square meters to one decimal place. Okay, so hopefully you've understood that. Given two sides and an included angle, we should be able to find the area of a triangle.